Okay, so in the process of looking to reduce the circuit to the most simple operating functions, remove the 3 coils which were being used as exploratory, I guess, devices. Now I'm only using the single coil, the single secondary. It's connected to the base. It's the normal tip 42C Slayer exciter circuit. 2 5-turn planar coils pressed together, offset about from the same distance from the top as the primary coil is from the bottom, which seems to give the best output. I guess that's not a surprise, seeing as the secondary coil is acting as a sort of a step-up conduction functionary. Anyway, what's pulling out of here now, though, after removing all the extra coils, is about 8 volts, or it was 8 volts. Power's coming down a bit. So that's off the running circuit. It's collecting that, so I'm driving it with 1.5 volts. It's filling a 4.7 UF capacitor. This guy over here, filling that up to about 8 volts. So I have a 9 volt actually wired up here. 9 volt as well, which is open currently. But you see the voltage shift as I touch the battery. That's interesting, huh? If I take my fingers off, it goes back up to 8 volts. I touch it, I seem to sink some amount of that voltage that's being accumulated. So if I open that up, and I shut this off at the 1.5 volts. 1.5 volts is disconnected from the circuit. Voltage is dropping out. So let's connect up the 9 volts. And it's connected. So 9 volts is noting 17, 18 volts. Let me get my hand off the battery. So 9 volts. You only get about a doubling factor for the higher voltage input. A little bit of arcing, sparking. Let's see. Kind of see the purple there. Very limited at 9 volts. But it's charging a capacitor to about 16 volts. Unfortunately, my lowest rated side acts are 22 volts for breakover. So I burned up a whole batch of 9 volts. So now I got to figure out a better way to go at the input. Just higher capacity batteries, or I'll go to a 12 volt battery, maybe a 7 amp hour to start, since it seems to draw about 600 milliamps, which is a lot. You'd almost need a 14 amp hour battery to be able to supply a 600 milliamp at a C20 rate. So it's a pretty big battery, frankly. And these guys over here, each one of those is a 7 amp hour. So 2 of those together would make a 14 amp hour and give me a 600 milliamp 20-hour draw of them. But you have to be able to feed back what you're pulling out. So if you're taking 12 volts, 600 milliamps out, you know, that's a little over 7 watts, 6-7 watts, somewhere in there. So you got to be drawing out via this coil, via the discharge pulses at 17 volts, or 17.58 volts, 5 volts. Okay, so discharging that out, probably via very low resistance conductors and very high instant switching devices. The harder you switch, the higher you get a current pulse. Yeah, a little stutter going. Anyway, that's the idea. And it looks like you don't need another Slayer set. You only need 1 coil, this main one. So the next thing I'm going to try to do is to take the other exciter, the other 8-turn exciter, and put it maybe another quarter of the way up here, and run it over on the other side and tune it in at a different frequency, and see what that does in terms of charging the capacity, just using the single coil. So yeah, more stuff to play with. Curious finding anyway. You don't need to have more than 1 coil. the one secondary is good, and then use that as a conductor to the tertiary. It's an open magnetic system, frankly, right? You're having a discharge impulse. In this case, actually, it's more of an RF/electric system because the magnetic field is relatively small and the electric field is relatively high because of the frequency. So the frequency electrifies the secondary. The secondary's electrification is held at rough equal distance from the end poles, from where the wave is, building up its own standing reflections from both ends, which is why this seems to be the biggest pickup point, right? Because it's about the equidistant from the bottom to this side from the top, right? Equal distances. So adding another one at the midpoint may cause a different modulation of the waveform, and it may result in an increase or decrease, or I don't know. Another thing to try is also add higher turn coils for collection. So that's another thing to go at. But it's the biggest magnification ratio, right? It's from the 1.5 volts up to the 8 volts. You're getting 6 times roughly, right, voltage output. While with a 9 volt, you're barely getting double at about 17 volts now, as the battery's discharging the higher voltage, resulting in a higher current drop, resulting in a quicker discharge. And this battery is pretty used already. I'll disconnect that bad boy. Anyway, that's what it is. One coil, and then you can make other coils for pickup coils, and then if you're going to try and offset it, try and space them both equally from the opposite ends of the coil into the coil. See what you can develop. Anyway, there you go.